Okay, guys, today is Thursday the 15th, and I'm introducing logarithms. Just a little review of what you learned last year. First of all, I need you to understand, and I need you to remember that logs are just exponents. It's very important. So a logarithm will always equal the exponent. So if I have a base A logarithm of b equals x, then x is the exponent, because a logarithm is, there's your equal sign, a logarithm is an exponent. So if I'm going to take this logarithm, I'm going to write it in exponential form, then it looks something like this. You've got the base. You can think of it as it's sliding over here and becoming the base of that exponent. So we would say that b equals a to the x, because the logarithm equals the exponent. So the base of the log slides over here and becomes the base of the exponent. If you had Miss May last year, she liked to use the loop-to-loop. So we would say that a to the x, and you loop around, equals b. So a to the x equals b. So that little loop will give you the exponential form. There's some special logs that I need to remind you of. The first one is the common log. Which is just log with no base. And what that means is you've got a log with a base of 10. The other one is the natural log. Which we would say, which looks like that, lnx, which is a log with a base of e, or 2.718. Just a quick reminder of what the graph looks like. An exponential looks something like this. That point goes through, or the graph goes through 0, 1. So let's say that this is y equals 10 to the x. And I've got an asymptote at y equals 0. Then the logarithm, the common log graph, looks like that, with a vertical asymptote at x equals 0. So if this point is 0, 1, then this point right here is 1, 0. So you can see the reflection over that diagonal, y equals x, because they're inverses of each other. Now I'm just going to go through a few examples. First of all, I want you to write a base 4 logarithm of 64 equals 3. We're going to write that in exponential form. So just like we talked about earlier, the 4 slides over here, so 4 to the 3 equals 64. And then always double check and just make sure that your exponential makes sense. You can double check yourself there. So if I had a base 36 logarithm of 6 equals 1/2, then we can say 36 to the 1/2 equals 6, which is just a square root. Square root of 36. Okay, next example. Let's say you're asked to evaluate f of x equals the base 2 logarithm of x when x equals 16.
I wanted to make this time.
So if I have a base 2 logarithm of 16, if I want to evaluate that, I can set it equal to anything. So if I set that equal to x, then I can put it in exponential form. And then we can use the one-to-one product, the one-to-one property like we did yesterday, and I can rewrite 16 with the same base. So if I say 2 to the 4th equals 2 to the x, well then x has to equal 4, right there. Okay, let me show you a couple more, mainly just some shortcuts that that you'll be able to use. If you see something like this, where you've got a base 3 logarithm of 3 to the 4th, well, same thing, if I set that equal to x and put it in exponential form, then you can get your answer. But really the shortcut is this: whenever the base of the logarithm equals the base of that exponent, then your answer is going to be that exponent. So here's some different ones. If I've got a common log of 10, let's say the common log of 10 squared. My base is 10, this base of the exponent is 10, so this will just equal 2. Here's another one. Natural log of e is just going to equal 1, whatever that exponent is, because my base is also e. Last one I want to show you is anytime you take a logarithm of 1, and it doesn't matter what the base is. Let's say the base is pi over 2. Well, pi over 2 to the what equals 1. Well, then x has to be 0. So anytime you're taking a logarithm of 1, you're going to get 0. So let's say we have a base of 78.692. 1. It's going to equal 0. So there you go, some helpful information about logarithms. I hope it helps.